All right, here we go. Good morning. First of all, how we doing? I'm optimistic about today. I'm optimistic. I can tell by the looks on your faces you're ready to go, ready to focus. All right, the week ahead. It's a pretty ambitious schedule, just to be honest. Hey guys, we're ready to go. Let's go. 7-3 day 2. Today is the washer method. The washer method, or if you're from Southern Ohio, the washer method. Then we'll do another day on that tomorrow. Then, so this won't really affect you guys too much, but we'll go over the homework on Wednesday. Wrap up, if you have anything else to wrap up. Quiz review, kind of Wednesday, Thursday, and then quiz Friday. All right, 7-2, 7-3. So areas between curves, top minus bottom, right minus left, 7-2. Then volumes of revolution. Okay, so we're going to have disk method, washer method, and then geometric cross-section method. All right, it's a little bit different. So I made an executive decision. I looked ahead last year's agenda, and it was going to take an extra week and a couple days to go over what's called the cylindrical shell method. All right, cylindrical shell method. I think our time would be better spent doing some AP review. So I didn't want you guys to miss out on a whole week of AP review. So we're going to skip the shell method. It's not an AP tested topic. All right. But it is helpful at some points, but not necessary. So you can get away with the other methods. You don't have to use the shell method on the AP test. So we're going to skip that because there was a whole couple several days of it. It's kind of complicated. And then a quiz review and a quiz. So that's going to save us at least a week. So I think that's going to be well spent with all these messed up schedules. So that'll help for sure. All right. Today, questions on the homework first. We did 7 through 12. So 8, I'll go over the evens first. 8 was 6 pi. 10, you may have had it as a decimal. In the best form, it's pi squared over 16. Pi squared over 16. You can type that in and see if you got the same thing decimal-wise. But write down pi squared over 16 if you want to check in a little bit. And 12 was 128 pi over 7. 128 pi over 7. Is your calculator giving you those nice pi answers? Okay, there's ways to get around it. It might frustrate you to write like that, but then if it's giving you the decimal, you don't really have an option to get the precise answer. You always have the option of going from in terms of pi, then control enter to get the decimal approximation. All right. Any of the homework questions you'd like to discuss? All right, that was the disk method. What was the requirement of the disk method? We need to know that so that today when we do the washer method, we're like, oh, can't do the disk method. What was the requirement? Look.
No gaps.
No gaps. I like it. No gaps. Mind the gap. So let's say we have this guy, and I'm not even going to do the problem. Ready? This guy. Around the x-axis. To disk method or not to disk method? I didn't think about it, but we can do a game today. We might be able to do another game. Disk method. All right. This guy around the y-axis. You see the gap? See the gap? Now, what gap am I talking about? I'm talking about taking this guy and going like this. Ready? Can you picture it? I feel like our motion and sound effects were enough for you to visualize it. Is it right? Oh, thank you. Appreciate it. Now, what's the problem? A cross section, ready? I'm going to be kind of wordy today. A cross section perpendicular to the axis of revolution is not solid. Back up for a minute. Ready? Let's take this guy around the x-axis again. Do you agree it would be a bullet bill, right? Remember that? Solid or empty inside? Solid. Just like you're understanding calculus, all right? Solid. Disc. Solid discs. So a cross section taken perpendicular with a knife, a cross section taken perpendicular to the axis of revolution is a solid disc, a solid circle, no gaps. Good? Next, around the y-axis. Around the y-axis. Ready? And then be careful, watch out. Okay. We're coming into three dimensions. Okay. Mason might have to lean back a little bit. Okay. When this comes out, ready? Around, okay. That's solid too, but ready? A cross section taken perpendicular to the axis of revolution. What is that? Slice it. Look at it. Cool. With a K. Yeah. Ready? If I were to take that circle, that's a solid disk. That's not it. There's a empty circle. At that y value, there is a outer circle, there's an inner circle. Are you with me? What's the stuff we're adding up? Well, it's the shaded stuff, right? It's the shaded stuff. It's that, empty inside. Okay? Empty inside. It's the shaded stuff. It's that ring. I like it. It's the aerobie, you know the disc I'm talking about? It's got a ring, empty inside. A washer. You know what a washer is? Bolt, nut, washer. The washer goes on the bolt. Okay, empty inside. Empty inside. You can't do solid discs here, can you? You can't add up pi r squares because they're not solid. Are you with me? We're going to have to take away the emptiness. Okay? Good life lesson. Take away the emptiness. Let's practice visualizing. What would you describe this as? What shape? After it's created volume. What do you think? A bunt cake. I like it. A bunt cake. What else? Let's use our imaginations. Kind of a dangerous swimming pool.
Cylindrical funnel.
A cylindrical funnel that's useless. It can't empty anything, can it? Here's why I did that. Because if I would have said a cylindrical funnel, you would have been the guy that said, "Oh, that's a useless funnel." Right? Anybody else? This is imagination time. I was kind of mean about that. Chad's need that every once in a while. Anyway, we now have the need for a new method. Do you agree? There's a need for a new method. What happens? What happens if there's gaps? It's called the washer method. It's called the washer method. This is used when the region being revolved is not completely connected to the axis of revolution. The cross sections are exactly that. They are washers. Circles with holes in the center. Do we agree that cross sections are still going to be circular, though? They're going to be some sort of circle cross section. So it makes sense that we're going to do a pi r squared. We just need to take away the pi r squared that's empty. They have been sharpening this stinking pencil every period today, all period. Listen for it. Like, even if it means ignoring my teaching, like, listen for it. I'm just kidding. Don't listen. Kylie, did you notice that already?
No, not at all. Not the slightest. I don't even hear anything. I don't know what you're talking about.
Besides the strong in this class. There it is again. Again. They're calling mechanical pencils. I should walk over with a box. Just take it.
Slowly walk out with the.
No, guys, they're
pencil
coloring.
sharpeners
Just go
and
in there and
Is
unplug
that what they're
it.
doing? Are they using? I figure they're probably using colored pencils.
Just go in there and unplug the pencil sharpener and just come back. Throw it against the wall. Just take it with you. And then we'll sharpen our pencils.
Show them, give them the taste of our own medicine.
All day. All right. There's our formula for volume. Now, you can do a pi r squared. You can do two integrals, but don't do it. All right. Pi r squared minus pi r squared. Pi r squared minus pi r squared. Now be careful. The one mistake students make, and I hate to introduce possible mistakes, but it's going to happen, so I'm trying to keep you away from it. All right? Do not do do you guys agree? That's not correct. Subtracting the r's first, then squaring them. Algebraically, that's not the same. Are we okay with that? Yes? All right. Some of you aren't paying attention. You're still going to mess up. I warned you. I warned you. Now they got like a remix, like of a pencil sharpener. Like you could do like a remix graph with it. Kind of, it's got that like. All right. So here's my attempt. Take this shape. Do you agree? The first thing you should notice is this is the shaded region. That shape is not connected. Now be careful. I need to be careful here. I almost minced my own words. Not completely connected. Do you see it? It's connected to the axis it's going around. It's just not completely connected, meaning there's going to be gaps, right? So when you revolve this around the y-axis, we have the coin vortex, but it's kind of useless. Do you agree? It's a useless coin vortex. But that's the shape we're going to get. Now, here's how we're going to do this. Do you agree? There's an outer radius, there's a capital R, and there's an inner radius, little r. If I were to take one cross section at let's say y equals 1, do we agree that would be a pretty decent cross section of what it's going to look like? Would you agree with that? What is my outer radius? Anyone want to take a stab at it? Tom? Yeah, out to the blue line, right? So from the axis out to the blue line. Everybody okay with that? But if I calculate that, it's too much. I have to take away the area of the inner circle, which is the, I'm going to do it in red because it's out to the red curve at the same value. Do you agree? So it's, Ava, are you good, or is that confusing? Be honest with me. You good? All right. What's the purple radius? What's capital R? Let's say, let's make a name for this. Let's say this is y equals 2x. Be careful. What's the radius? What's that purple length? And it's changing, right? It's getting greater as y increases. So give me a function or a relation. Cool. Here, y over 2. Well, if y equals 2x, then if I solve for x, isn't it y divided by 2? Oh, so we're going to have to do this with y's in it, aren't we? Why? Why? Because that's an x value, isn't it? This is an x value. It's going side to side. It's an x value. It's how far this thing is away from the y-axis. If I say how long is this horizontal line, you wouldn't say y equals. You would say x equals. X equals 2, x equals 3, x equals 4. X equals whatever the y value is divided by 2. Are you with me? So capital R is y over 2. What's little r? What's the inner radius here? Well, let's say that graph is y equals the square root of x. Then x equals y squared. Are we going to have x bounds or y bounds? Going around the y-axis. Going around the y-axis. Y bounds. Guys, listen. How are you stacking things? Because integrals do the stacking. Are you stacking them left to right? Or are you stacking the bottom up? Look, these are washers being stacked from y equals 0 up to y equals 2. Stack, 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 stack. You're adding up thicknesses of y. Oh, dy. Makes sense. And I don't know that. I just made up functions for these. But in general, this is what it would look like. Y equals 0 to y equals 2. Pi outer radius squared minus pi inner radius squared dy. That would give you the volume when that thing gets revolved around the y-axis. Okay? So let's make a quick rule, because some of you like little rules. All right? If you're now these are only for the disk and washer methods. These are only for the disk and washer methods. If you're going around a horizontal line, are you going to have dx's or dy's? If you're going around a horizontal line, dx's. Because think about it. Watch up here. If I'm revolving around a horizontal line, isn't this thing spinning this way? And aren't I stacking up left to right? I'm stacking left to right. Do you agree? But if I spin it around this way, around a vertical line, I'm stacking them bottom up. I'm doing dy's. Does that rule make sense to you? Now, we've only done the x-axis, y-axis. We did do y equals 6 on that one AP problem. But horizontal line, x's. Vertical line, y's. Okay? So, we did this problem last week. Y equals radical x and the x-axis. So I've already given you the region. All right? We did it around the x-axis, correct? And which method did we use since it was around the x-axis? Just because it was completely connected to the x-axis on the interval that we were revolving, 0 to 4. What if we go around the y-axis? Here we go. First of all, the first question you should ask yourself on every one of these problems, is that yellow region? Not is it connected? Is it completely connected? Is it solid? Are there going to be gaps? And if we go around the y-axis, there are going to be gaps. As soon as you see that, you should write down washer method. As soon as you decide washer method, you have a capital R and you have a little r. Are these going to have x's in them or x's in them or y's in them? Y's. So my bounds are going to be y's. All right. Well, wait a minute. We're going to pick some value from there to there, some y value. Let's pick that y value. And we're going to decide, where do I draw my outer radius to? Now, here's a mistake the students will make. In this case, you are not drawing in a did I use the words representative rectangle? Did I use that word yet? Remember how 7.2, flashback, section 7.2. What's the first thing I told you to draw in? Draw in a rectangle. Right minus left. We're not doing that today. Do you agree? That is what's getting revolved, but that's not the function where we're revolving. We're doing an outer circle, inner circle, subtracting them, and we're left with that cross-sectional area. Do you agree with that? But don't draw that in. That'll mess you up. Volume, that'll mess you up. You want to draw in your radius. Well, isn't a radius from, ready? I'm spinning something on a string around my hand. The radius is how far that thing is away from my hand. What's the rotisserie here? What's my hand? It's the y-axis. What's the outermost radius?
4.
Agree or disagree? Four. X equals 4? Y equals 4. X equals 4. This is the line. X equals 4. So is my outer radius x equals 4? And it's x equals 4. Now, if I were to spin around, if I were to take x equals 4 and revolve it around the y-axis, I would have a solid cylinder, wouldn't I? That would be a solid cylinder. But I don't want that solid cylinder. I have to take away at the same value. Now, I kind of broke my own rule. I was going to do it at this y value here. Well, let's stick with it. It's at that y value. What is my inner radius at that same y value? Well, it's this function. That function was y equals radical x. But I'm not putting radical x there. I'm putting, it's an x value. X equals y squared. Now, just as an example here, here's what you should do. Okay, if you're on a quiz and you're unsure about this, plug in a y value like 1. Y equals 1. When y equals 1, what's x? 1. Is that length 1? And you could test it in the function, right? Or when y is 2, what's x? Because you're finding out how far out that radius has to go. All right. Now there's your outer radius. There's your inner radius. Our volume is going to be stacking these things from y equals 0 up to, wait a minute. Where do these two functions, relations really, where do these relations cross? At y equals? Y equals 2? So y equals 0 up to y equals 2. Pi times 4 squared minus pi times y squared dy. Does that make sense? Everybody type that in. Now accepting answers.
128 pi over 5.
Anybody confirm? Thank you. 128 pi over 5. Just out of curiosity, what was the volume when we spun this thing around the x-axis? It was 8 pi, wasn't it? What's greater? (128 over pi is more than 8. You guys agree? Yes? What is it? 128 over 8. Close to 10 times as much volume? Why? Big idea. I need you guys to listen. Big idea. Why is this thing a lot more volume spinning around the y-axis than it was around the x-axis? A lot more. Okay.
Because it's wider than this tall.
Yeah, and it good. That's definitely part of it. What else? What do you want to keep going with that? Like it's wider, but what does that have to do with creating volume?
That's
That's fine. It's a good start.
It's wider because it's farther away from the axis, so it revolves around like a wider spot because it's spaced away from the circle.
Yeah, those things together. Yeah, for sure. It's the same reason why. Who are my track people? It's the same reason why you have to offset your starting point on a race that is more than 100 meters. Right. Why do you have to stagger it? Because if you're in the outer lap, you have to run farther. You're farther away from the center. You have to run farther than the inner person, right? That's why you have to stagger the start. This thing's going farther. Now think about it in 3 dimensions. You take an area and revolve it. When that area has to travel farther, it creates a bigger volume, doesn't it? Make sense? Remember that word swath? Carves out a bigger swath as it revolves around the y-axis. All right, fun stuff. Do you guys think is this boring to you? Is it? Oh, I'm sorry. It's fun. Like this is kind of fun. All right, now here's what's going to happen quite a bit. We're going to take an area, and to save you some time, we're going to take the same area, shaded, and revolve it around different lines. Okay, so go ahead and write this down. This is going to be used for the next few problems. I'm actually looking forward to hearing that sound the rest of the day now. Like when it goes away, you kind of miss it a little bit. There's your red phone. That phone. You guys ever dial on a rotary phone? I almost said rotisserie. You ever dial one? Grandma's house. All right. Find the volume of the solid formed by revolving the region bounded by the graphs. Y equals radical x. And y equals x squared. Now, here's the deal. If I say y equals radical x and y equals x squared, do you agree as soon as I go back to that word bounded, I can ignore the left part of x squared, right? I only need to pay attention to x is greater than 0. So I eliminate that in my mind. And now I'm seeing that region is my shaded region. And this is going to be the same region we're going to use for all parts of this problem. So it's worth writing out next to the functions. Y equals radical x. Y equals x squared. And your first objective is to rotate this around the x-axis. Now my first question for you, is there any line you could rotate it around where you will be using the disk method? No. So it's all washer, right? Washer for life. So start off with part A. Part A time. And if you're ambitious, the next one is y equals -3. So spicy. Have we located the pencil sharpener? Like, do we know where it is?
It's over in the corner. Like right up
Right by the door. Right by the door. Give easy access.
Like just walking, just yank it out of the bag. Just grab it from the bag. You just walking up there. Here comes another one. There he is.
Make sure you're typing these into the calculator. I'd rather you make a mistake right now than when you're on the AP test. All right, I would get in the habit of drawing your rotational arrow. Remind yourself, how is this thing being rotated? So we have an outer radius up to the blue curve, and inner radius up to the green curve. The first thing you should write is capital R. And are these going to have X's in them or have Y's in them? X's, right? So the outer radius is radical X. Inner radius is X squared. Volume. If you're more of a nerd, you could write out A of X or A of R squared. A capital A, little a, whatever you want to call it, is pi times radical X squared, and then little a is pi times X squared squared. And then put it into the volume. Or you can go straight to the volume formula. And remind yourself, are the bounds going to be left to right or bottom up? Are we stacking them from left to right? Or are we stacking them bottom up? Left to right. So we need X bounds, don't we? We need to go from X equals 0 to X equals... I heard 1. I heard 2. 1. 1x is 1. What's radical 1? What's 1 squared? 0 to 1. Pi outer radius squared minus pi inner radius squared dx. What'd you get? Huh? 3 pi over 10? Is it the same kid?
No, it's just like all the boys. I'm gonna fight an 8th grader.
That'd be entertaining. I mean, we discourage violence here at Lake High School. We always try to handle things rationally, without emotion first. All right, y equals -3. Ooh. Anybody tried this yet? Spicy. Ready? Y equals -3. Cole, what'd you get for the outer radius? You guys all hold on 1 second. Sorry, I asked and I'm pausing it. You guys all agree it's the distance from the hand or the rotisserie, if you're hungry, out to the outer function. Always that. Cool.
Radical x plus 3.
You guys agree or disagree? Do you agree it takes 3 units just to get up to the x-axis? 3 units just to get up to the x-axis. Plus radical x more to get up to the function. Or what's another way you can find length? Top function minus bottom, or top location minus bottom location. Watch it real quick. Top location, radical x. Bottom location, -3. That was fancy. Radical x minus a -3 is radical x plus 3. I did the teacher thing and I made it way more complicated than it needed to be. Right? Next.
That was your one shot.
It was. I was curious what I was going to do. Inner radius. Well, from that same location, isn't it? He wrote radical x plus 3. You could put 3 plus radical x. Isn't it x squared plus 3? Now, be careful. Isn't the process here? You guys don't lose track of what's actually happening. We're finding this area. We're finding this area. We're subtracting them. So we're doing a area of pi times that squared. We're doing a pi times that squared. And we're going to end up subtracting these in the integrand. So we are stacking these from still going from 0 to 1. Pi radical x plus 3 squared minus pi x squared plus 3 squared dx. Agree? Be careful. Make sure you put parentheses around the whole R. Wendy. Question? Go ahead, Wendy.
I just don't know how to get the bounds. Like, I get confused.
Do you agree?
Made sense.
What's that?
Why are they the same color?
Because we're still stacking these washers. These ones we were stacking from 0 to 1, right? Because that's where that region resided. This region still goes between 0 and 1. It's just going around a lower point. We're still stacking these from 0 to 1. They're just different washers. Do you agree? Like right here, this washer is going to go down to here. Close. This washer is going to go down. I'm off a little bit. But they're going to be smaller washers, but we're still stacking them from 0 to 1. Anybody get a value for that? And I'm trusting you here. 23 pi over 10? Confirm? 23 pi over 10. Is that more or less than part A? More because that same area is traveling farther, not further, farther. Distance. Further is a symbolic distance. Like I'm going to further my education. Farther is a physical distance. Have you thought about it? That's why it. Have we had this talk before?
No.
You know what Ford's slogan is? Ford, go. They had an ad campaign for a long time. It was go further. And I'm like, oh, that's interesting. Because they're not claiming to go farther. You go further with them. Interesting. Interesting. Now for the spicy one. Are you ready? Have you tried this one yet?
Yes.
Should we do the y-axis first? Let's do the y-axis first. Take this thing around the y-axis. Around the y-axis.
Line. You don't want
Really?
kids waiting to sharpen the pencil.
That motor's gonna burn out by the end of the day.
He's struggling.
It sounds like it's on his last leg already.
There's another one. Another one just got the line.
I hear some good conversations about in terms of why. All right, what'd you get for capital R? Square root of y? What'd you get for little r? Y squared? Bounds. Well, this time they are y bounds, but still 1, right? So y equals 0 to y equals 1. There's another common error right there. Hey guys, listen. There's another common error. If I give you 2 problems in one, the bounds you did for the x's, students will then use those bounds for the y's. So just a common mistake. All right. Make sure you're paying attention to the intersection points, both x and y. All right, we're going to do pi radical y squared minus pi y squared squared. I feel like we've done this one. Yes? What did we get? 10? 3 pi over 10? 3 pi over 10. Wait a minute. Where did we see that before? Why was it the same? Ooh. Next level question. Why was this the same as when we went around the x? Symmetry? Because these two functions are inverse. Ooh, Robert. Gold star. Vocabulary. They're inverses of one another. Meaning that, watch, they're symmetric about the line. Good, y equals x. And therefore, if you rotate it around the x-axis, it's the same as rotating around the y. Make sense? Done.
Can you use a disk method if they said to revolve it around the line?
Y equals x. I'm not going to do that, though. Yeah. We'll never go around a non-horizontal or vertical line. All right, last problem for today. What about x equals -2? That's a problem. Do you all agree x equals -2 is a vertical line? Do we all agree? This is the outer radius. What is the outer radius? Agree? 2 plus the square root of y. 2 plus the square root of y. Inner radius. 2 plus radical y. 2, nope. I wrote it wrong, sorry. 2 plus y squared. Two plus y squared. Volume 0 to 1. Pi outer radius squared minus pi inner radius squared dy. Have you noticed we need to be very careful with the parentheses here? I mean, it's tedious when you have to type it out. Anybody get an answer? 49 pi over what?
30.
This one would look like a beautiful spring flower. Okay? Beautiful spring flower. In blue. Or an onion ring. All right. Homework for tonight. Now, when it says, watch up here. When you do number 17, do it as it is. And then parentheses means do it again, this time with around y equals -2. Then do 19. Then do 21 as it is. And then around y equals 4. So only for 17 and 21 are you going to be doing them around what it asks for, and then around a new axis of revolution. I hope you have a wonderful Monday, and I hope you all stay sharp, just like those colored pencils that are not. I guess they're not staying sharp.